Hello, my name is Mihin Wijegunawardana and my student ID is 2021-1542. My research topic is real-time emotion detection and mental health monitoring for remote employees. And my supervisor is Ms. Malcha. This is the agenda of the presentation. So I will start with the problem definition. With the rapid shift to remote work, employees often find themselves without timely support to monitor their emotional well-being and manage stress effectively. This lack of real-time intervention negatively impacts both mental health and productivity. Traditional workplace mechanisms such as face-to-face mental health assessment, informal peer interaction, and direct supervision are no longer accessible in remote work environments. Research shows that nearly 25% of employees suffer from undiagnosed stress, which directly affects their job performance. Furthermore, current emotion detection systems are often limited to controlled environment and rarely integrate multiple data sources like facial expression and psychological signals for accurate real-time monitoring. Without these capabilities, employees are left without effective personal and mental health support. This creates a significant gap, one that my project aims to address by introducing a cross-platform solution capable for detecting emotion and predicting stress in real time using facial and heart rate data. So moving on, the next is research gap. Although various emotion detection systems have been developed, many are many are not suitable for real-time application in remote work settings. For example, systems like the real-time employee emotion detection system rarely on only on webcam data and do not consider psychological indicators such as heart rate. This reduces their ability to accurately capture the emotional state of remote employees in dynamic environments. Moreover, while some systems are able to detect stress or emotional state, they fall short when it comes to providing meaningful personalized support. Most of these solutions do not offer real-time, context-aware interventions like music or therapy suggestions. This this leaves a gap transforming emotion and psychological data into actionable mental health support. Additionally, there is a underutilization of psychological data, especially heart rate variability, despite its proven relevant in stress and con- concentration monitoring. Although verbal technologies highlight the potential of these non-intuitive signals, their integration into an unfilled system for continuous mental health support in remote work is still lacking. My project attempts to bridge this gap through a solution that combines facial emotion recognition, heart rate analysis, and personalized music recommendation for real-time mental wellness support. So now let's look at the project aim. The main goal of my project is to develop a real-time emotion and stress detection system specifically designed for remote employees. Unlike traditional workplace setup, remote work lacks immediate support for mental health, which often leads to unnoticed emotional strain. The system aims to fill that gap by using facial expression and heart rate data to continuously monitor the user's emotional state in real time. To achieve this, the project employs machine learning techniques. It uses CNN to analyze facial emotion and random forest algorithms to interpret stress level from heart rate data. The models are trained on well-established dataset like FAR 2013 to ensure accurate detection across a range of emotional states. But the project doesn't stop at detection. It also provides a personalized mental health support. Based on the detected emotion and stress level, the system recommended music tracks as from a digital therapy. This makes the solution not just intelligent and real time, but also empathies and supportive, helping users maintain emotion balance and productivity. This is the system architecture of my real-time motion and stress reduction solutions, and structured across the three main tiers. In the data tier, the system utilizes the three key datasets. The face emotion dataset provide annotated facial images used to train emotion detection method models. The heart rate dataset contains physiological reading mapped to emotional state, enhancing stress prediction accuracy. Additionally, the music recommendation dataset links specific emotional and stress state to appropriate therapeutical music options. Moving on to the logic tier, the system begins with image reprocessing and augmentation to improve input quality. From there, feature extraction and image analysis identify emotional cues from facial expressions. Simultaneously, heart rate measurement models analyzing psychological signals for stress indicators. And CNN detects primary emotion like happiness, anger, and like sadness. And random forest classifier interprets the heart rate data to predict stress level. And support vector classifier combines facial and heart rate data to assess the potential of mental health issues. And finally, a support vector machine uses the emotional state to recommend personalized music therapy. And all backend processing is connected to the front end via web application integration, enabling seamless communication between logic and user interfaces. And when it comes to presentation there, users interact with the system through a web and mobile friendly interface. The homepage allows them to capture facial data via webcam and measure pulse using their mobile devices. The system processes this input in real time and displays the user's emotion and mental health analysis. If necessary, it is recommended calming music, offering instance personalized emotion support. This is the table outlines the core technologies used in developing the real-time emotion and stress detection system. The front end is developing using React for the web and the Flutter for the mobile interface. For machine learning and deep learning, the project uses TensorFlow, Keras, and skite-learning, learn for tasks such as model training, evaluation, and prediction. The OpenCV is utilized for the real-time image processing and facial emotion detection, and development is carried out in environment like Jupyter Notebook and VS Code and PyCharm. And now I move to the demonstration part. So I have used the FER 2013 dataset for emotion detection model. So this is the Jupyter Notebook where I trained the model and create files that will be used in PyCharm. In this emotion detection model, first I have create dataset path to a path to train and test. I created two folders training and validation folders, and I used 128 pixel grayscale images and set batch size for 64. Uh, in this code line, this code loads the pre-processed image data from directories for training and validation using Keras, and I use this code for the model building. And when it comes to conventional layers, uh, this code defined the deep convolutional neural network with multiple convolutional layers to extract features from input images. And it uses ReLU activation for batch normalization for stability and max pooling to reduce spatial dimensions and dropout for regularization, and the model gradually increased the number of filters to like capture complex pattern, and L2 regularization is likely L2 regularization used is added in deeper layers to prevent overfitting, and this is the model summary. And as I generate the confirmation matrix and have functions go like that. This Python script is designed to build health-related uh, predictive system using machine learning. It processes a dataset contains psychological lifestyle information such as heart rate, sleep hours, alcohol consumption, awakens during sleep, and smoking status. Primary objective is predict five key outcomes like stress level, sleep efficiency, REM sleep, and deep sleep and light sleep. Categor- Categorize data like smoking status uh, is converted into a binary format, and any missing values in the dataset are handled using means in infusions. And so this is the stress level uh, training code. This is the login page, and this is the sign up page, and I have already logged in. Let's go to login and enter the email. Already logged in using the test example, and enter the password and press sign in. And this is the dashboard, and you can see heart rate history, your feedback rating, and weekly therapy recommendation. Let's go to start new analyze, and we can capture the emotion from this. It's going to be happy, and I entered already the heart rate from the mobile device, and we can see the time is 7:40, and let's submit the process, and this is the recommendation, and this is result, and we can suggest a song and also the therapy, and you can see the music recommendation and the therapy recommendation. And this is the dashboard I already showed, and we can see the therapy history and feedback history, and we can see the last entered the heart rate, and we can recommend therapy recommendation and give the feedback like this and submit, and we can see the feedback history in, and this is the testing and evaluation. So this is section present the performance of emotion detection and stress prediction models. The facial emotion detection model achieved a testing accuracy of 81% and trained over 100 epochs with 449 badges per epoch. Performance metrics such as loss, uh, accuracy, and ROC curves were used to evaluate the model across multiple emotions, with AUC score indicating strong class separations. For stress prediction based on heart rate is random for a specifier achieved 99% accuracy, demonstrating high reliability to in detecting stress level from psychological signals. And let's move to the next slide, challenges and contribution. Mm. The system introduces several key contributions, including the integration of real-time emotion recognition and mental health tracking using facial expressions to heart rate data. It also delivered a personalized music-based therapy based on emotional and stress level, enhancing user well-being. Like the project advanced the use of machine learning, employing CNNs and random forest for improving mental health insight in remote work settings. And two major challenges were encountered during the development. First, synchronized data from camera and heart rate sensor in real time required extensive calibration and optimization. And second, model tuning with the FER 2013 dataset and limited psychological data demand multiple training cycle to achieve acceptable accuracy, which was resource intensive. And let's move to the next slide, novelty of the project. The novelty of this project lies in its multimodal real-time stress detection and response system. It uniquely combines facial emotion recognition and heart rate analysis to detect emotional state and stress level. Unlike conventional approach that focus on either emotions or health monitoring, this system offers a holistic solution by integrating personalized music-based interventions. It also supports cross-device functionalities with web-based emotion tracking and mobile-based heart rate input. And go to the next slide, limitation and future enhancement. The system presents a few limitations. Firstly, it relies on publicly available dataset like FR2013 and simulated heart rate data, which may not accurately capture the emotional and psychological uh, data for real-world remote workers. Secondly, the current prototype process discrete inputs rather than live continuous data stream, which limits its responsiveness and realism in real-time scenarios. To address these limitations, further enhancements include expanding the dataset to include real-world samples from device demography and integrating multimodal inputs such as facial expression, heart rate, and voice tone to enhance emotional accuracy. Additionally, the system can be improved by incorporating social media and web activity analysis to detect passive emotional cues when the biometric data is unavailable. And finally, linking emotional state with task performance could um, enable productivity tracking and support long-term mental health monitoring. And we go to the conclusion and achievements like successful development of real-time system combination, facial emotion detection, and heart rate analysis detects stress level and recommended music-based therapy addressing the unique challenges of remote workers. And new skill is the gained hand-on experience implementing CNNs and random forest classifier, while also learning how to handle real-time inputs across the web and mobile platforms, and use of existing skills and leverage existing experience in front-end and back-end web technologies and database integration to build functional cross-platform system for both data input and visual feedbacks. Thank you.